The commercial grain bin arrived on a flatbed truck at Harlan Seifert's place in October of 1961, and Lyle Kester watched it from the county road while he was driving to the elevator. Harlan had been talking about the new bin since July. A Butler Grain Systems unit, 18 feet in diameter, 14-foot eave height, corrugated steel panels, a 2,400 bushel capacity. He'd gotten a co-op financing deal at 4.5% over 5 years. The monthly payment was $100. Lyle counted the trucks in the installation convoy, the flatbed carrying the panels, a second truck with the floor hardware and aeration equipment, a company installation crew of 4 men. He drove on to the elevator. He was 47 years old, had farmed 240 acres of Saline County, Kansas, corn and milo ground since 1938. The farm ran on the east side of Salina, flat ground, good silt loam. Tile drained through the 1940s when the Federal Drainage Assistance Program had made it possible. He'd been storing grain in rented space at the elevator for 23 years, paying the commercial storage rate and watching the bin situation across the county shift away from on-farm crib storage toward the corrugated steel bins that had been appearing on Saline County farms since the mid-1950s. The storage rate at the elevator was 0.020 tons per bushel per month. He was storing an average of 8,000 bushels at any given time across the fall and winter. That was 187 days per month in storage costs. Across a typical 7-month storage period from harvest through the following spring, $1,130 per year. He had been paying that for 23 years, $28,936 in cumulative storage costs. He'd written that number on the inside cover of the farm notebook in June of 1961. He'd looked at it 3 times since. A Butler bin like Harlan's was $5,800 installed, without financing charges. He drove to the elevator and unloaded. On the way home, he stopped at the Salina Library and checked out 2 books on steel construction and 1 on welding. He had been welding since 1943. Not professionally, farm welding, the kind where you fixed what broke rather than building what you needed. His Lincoln SA-200 gas welder had been on the farm since 1951, bought used from a pipeline company that had retired the machine after a project. He'd taught himself shielded metal arc welding from a Lincoln Electric instruction pamphlet and from watching the man at the farm supply repair shop in Salina for 2 seasons before he bought the machine. He could weld mild steel reliably. He could weld flat. He could weld vertical. He could weld overhead in a pinch, though he didn't like it. What he couldn't do was weld corrugated steel panels to the dimensional tolerances that a commercial bin's interlocking panel system required. He recognized that problem in the 2nd week of reading. The commercial bin's corrugated panels were factory-formed to precise dimensions and locked together through interlocking seams that didn't require welding. The corrugation provided both the structural strength and the sealing mechanism. A farmer trying to replicate that system without a metal-forming press was solving the wrong problem. He set the corrugated panel approach aside. He went back to the fundamentals. What did a grain bin need to do? Hold grain, keep moisture out, allow aeration, be accessible for loading and unloading, hold up under the lateral pressure of grain against the wall, the hydrostatic analog pressure that grain exerted on any containing structure, which was significant and which structural engineers had specific formulas for calculating. He checked one of those formulas out of the Salina Library. It was in a Kansas State University Extension bulletin on farm storage structures, and it gave the lateral pressure of grain on a bin wall in pounds per square foot as a function of grain depth and the grain's angle of internal friction. He worked the calculation for corn at 12 feet of depth. He worked it for 2 bin wall geometries, the commercial corrugated cylinder and a flat panel welded cylinder of his own construction. A flat panel welded cylinder of 1/4 inch mild steel plate, he calculated, could hold the lateral grain pressure without buckling at a diameter of 12 feet. Smaller than the Butler unit, but within the range he needed. The critical variable was the ring stiffeners. Circumferential rings of angle iron welded to the exterior of the cylinder at vertical intervals, which converted the flat plate from a simple membrane into a stiffened shell. He worked the stiffener sizing from first principles and from the extension bulletin. He wrote his design on a legal pad. 12-foot diameter cylinder, 14 feet tall, 1/4 inch mild steel plate for the shell, 3 inch by 3 inch by 1/4 inch angle iron ring stiffeners at 24 inch vertical spacing. A flat bottom of 1/4 inch plate on a concrete footing. A conical roof of 12-gauge sheet steel on a simple rafter frame. Capacity, approximately 1/600 bushels. He needed 2 bins. He bought the steel in January of 1962 from a steel service center in Salina. He brought the design specifications, and the purchase agent walked the order with him. For 2 bins, mild steel plate, 1/4 inch, for the cylinder walls and floors, 2,800 pounds. At $9 per pound, 252. Angle iron, 3 by 3 by 1/4 inch, for ring stiffeners and base ring, 340 pounds. At $0.09 per pound, 3060. 12-gauge sheet steel for the roof cones, 180 pounds. At $0.085 per pound, 1530. Structural tubing for the roof rafters, 80 pounds. At $0.09 per pound, 720. Welding rod, Lincoln 6011, 25-pound cans, 1840 for 2 cans. Concrete for the footings, poured himself. Rented mixer, $22 in material. Roof vents, screened, from a farm supply catalog, $12 access hatches, 2 per bin. Fabricated himself from scrap plate. Total materials for 2 1/600 bushel bins, $357.50 plus $90 in miscellaneous. Grinding discs, wire brush wheels for the welder, caulk for the roof cone seams, paint. Grand total, $47.50. He was $250 under the budget he'd set himself. He told Laverne what the materials had cost. She said that seemed all right. He said he thought so. He laid out the first bin floor in the equipment yard on a Saturday in February, scribing the 12-foot diameter circle on the 1/4 inch plate with a trammel, a stick with a nail at one end and a scribe at the other, pivoted from the plate's center point. He cut the circle with a cutting torch, working slowly around the scribed line, keeping the cut within 1/80 inch of the line. He rolled the cylinder wall sections by hand. Rolling mild steel plate to a 6-foot radius was not practical by hand, but he'd solved that problem in December. He cut the shell plate into 24-inch wide strips, each strip being 1 section of wall height. He welded pairs of strips at their ends to form 48-inch wide sections. He then beat each section to an approximate curve over the horn of his anvil and tack welded them to the floor plate at the base, checking the radius with a curved template he'd cut from plywood. The tack welds held the sections in position while he welded the vertical seams fully, alternating sides to control distortion. Weld 2 inches on one side, move across to the opposite seam, weld 2 inches, come back. The bin grew in sections, each section welded to the adjacent section and to the base ring. It was not a smooth cylinder. The seams were visible. The plate showed the hammer marks from the anvil work. The ring stiffeners gave the exterior a banded appearance that bore no resemblance to the factory-formed, corrugated look of the Butler unit going up on Harlan Seifert's farm. It held 6-inch weld beads. It was straight within 2 inches of true circle at the top when he checked it with a string line. He roofed the first bin in April. The cone frame went up in an afternoon. Structural tubing rafters meeting at a center cap. The 12-gauge sheet steel sheets laid over the rafters and welded at the seams. He caulked the seams with roofing compound. He painted both bins in May with a red oxide primer and a gray top coat from the farm supply. He filled the first bin in October of 1962. Earl Vogt, who farmed 180 acres adjacent to Lyle's south boundary, drove past the bins in August on his way to the elevator. He pulled over and looked from the road. He drove to the farm that evening and asked what the bins were. Lyle told him. Earl looked at them from the driveway for a while. He said they looked handmade. Lyle said they were. Earl said the seams were showing. Lyle said they were full penetration welds. Earl said he supposed that was what mattered. He looked at them another minute. He drove home. He bought a Butler unit the following spring. 6,200 installed by then. The price had moved up from 1961. He mentioned it at the co-op in June. Lyle said it sounded like a good bin. The county extension agent in Salina, a man named Dwight Parrish, drove out to the farm in the fall of 1962 after harvest. He'd heard about the bins from the elevator manager, who had commented on the test weights coming out of the new on-farm storage. He walked around both bins, examined the weld seams, looked at the ring stiffener spacing, looked at the roof cone. He asked how Lyle had sized the wall plate and the stiffeners. Lyle showed him the legal pad with the calculations. Parrish looked at the grain pressure formula and the stiffener sizing work. He was quiet for a moment. He said the calculation was conservative. Lyle had used a factor of safety in the stiffener sizing that was approximately 1.6, which was higher than the minimum he'd have needed. Lyle said he'd rather be over than under. Parrish said that was a reasonable position. He asked the total material cost. Lyle told him. Parrish looked at the bins again. He said he'd like to include the project in the extension's annual farm management bulletin. Lyle said that was fine with him if it was useful. Parrish wrote a 2-page summary for the 1963 Saline County Extension Farm Management Bulletin. He described the bin design, diameter, height, plate thickness, stiffener spacing, and the material cost. He described the storage capacity and the cost per bushel of capacity stored. He compared the cost to commercial bin pricing. Commercial Butler bin, 2,400 bushels, installed 5,800. Cost per bushel, 2,040 tows. Lyle's bins, 3,200 total bushels, materials, 447.50. Cost per bushel of capacity, 14. He let both numbers sit on the same line. He noted the bins had been constructed using standard farm welding equipment and materials available from commercial steel suppliers. He did not call the design replicable by any farmer. He noted that the project required welding proficiency and basic structural calculation ability that were not universally present. He included the legal pad calculations as an appendix. Lyle filled both bins every fall from 1962 through 1984. 23 seasons. He tracked the grain temperature and moisture through every storage period with a probe thermometer he lowered through the roof hatch on a cable, checking every 2 weeks from October through May. The readings recorded in a log he kept in the grain storage notebook. He never lost grain to heating. The commercial storage rate he'd been paying had risen from $0.022 per bushel per month in 1961 to $0.41 per bushel per month by 1975, and higher after that. His 8,000 bushel storage need, had he continued using the elevator, would have cost him approximately $2,800 per year by 1975. The on-farm bins had eliminated that cost entirely. By 1984, 23 years of saved storage costs at rising rates. The avoided cost was approximately $31,000. Against a material investment of $447.50 and his own labor. He wrote that number in the farm notebook in November of 1984. He didn't show it to anyone. Earl Vogt's Butler bin had been replaced once, in 1978, when the corrugated panels had begun to show through rust at the bottom seam from years of moisture contact at the floor line. The replacement cost, $7,400 for the new bin, installed. Lyle's bins showed surface rust at the lower ring stiffeners in 1978. He wire brushed the rust and spot painted. 2 afternoons, his own time. The bins were still standing when Lyle retired in 1987 and his son Dennis took the farm. Dennis used them for corn storage through 1994 when the operation expanded to the point where larger commercial bins made operational sense. He had 2 10,000-bushel commercial units installed that fall. He left Lyle's bins standing. He used them for seed corn storage through 2012. 50 years from when Lyle had filled the first one in October of 1962. 50 years. The weld seams were still holding. The ring stiffeners were still carrying the load. The roof cones had been recaulked twice. Dennis had done it in 1989 and again in 2001, the same roofing compound from the farm supply, the same application by hand along the seam lines. The bins came down in 2013 when Dennis needed the equipment yard space for a new grain handling setup. He cut them apart with a plasma cutter, the same task in reverse from what Lyle had done with a cutting torch in February of 1962. The plate steel was 51 years old. It was still 1/4 inch plate, not corroded through, not thinned by the rust. Full section, the original gauge, the weld beads still prominent along every seam. He sold the cut steel to a scrap dealer in Salina. The scrap dealer said the steel was in better shape than most scrap he got from farm equipment that was 20 years old, let alone 50. Dennis said his father had primed it twice. The scrap dealer said that was it. Harlan Seifert's Butler bin, the one Lyle had watched arrive on the flatbed in October of 1961, was replaced in 1979, 18 years after installation, when the floor had begun to buckle from subgrade settling, and the panel seams were showing separation at the lower courses. The legal pad with Lyle's structural calculations was in the farm files when Dennis cleared the office in 1987. He looked at it for a while before he filed it with the other papers his father had kept. The legal pad is still in the filing cabinet. The calculation for the ring stiffener spacing, 24-inch vertical intervals, 3x3 by 1 4-inch angle iron, sized to hold the lateral pressure of corn at 12 feet of depth, is on the second page in Lyle's handwriting. It was right. He'd known it was right before he bought the steel. He bought the steel anyway and proved it.